Next question. Find R equivalent seen from terminals A and B. Okay, very good. So this circuit is given and we would like to find R equivalent. So as I mentioned in the class, if you're given such a problem and there's a dependent source there, so what you have to do is you have to use a voltage source. So as if you are connecting your circuit to a voltage source, Vs, and then you look at Is, and R equivalent is basically Vs over Is. So this is how you solve this kind of problem. You need to find R equivalent, and it's not that just you only have resistors, but you also have a dependent source. So you put a test voltage, we call this test voltage. So as if you're doing a test voltage, you put a test voltage and then you look at the current, and then R equivalent is Vs over Is. Okay, so in other words, this becomes Vs, and then this becomes R equivalent, and this is Is. That's why we say R equal to V over I. Okay, so now let's do that. Let's basically solve this circuit with including Vs. And just probably we need to do some KVLs and KCLs and find the relationship between Vs and Is to find the Vs over Is. Okay, so by looking at this, again, so there is a voltage source here. So the loop that I would pick for the KVL is gonna be this loop. I will not go through the current source. Okay, so that the outer loop is better. So let's do this. So we do the KVL. So negative Vs come here plus 3 Is. Remember, we call this also Is, right? 3 Is. And then we come here. Let's call this negative Vx, okay? Negative Vx. But you could also, because also we are here, I don't know, call this I1 or let's practice this. If this is Vx and this is Ix, and therefore this is Ix, let's see what happens. Okay. So again, from here, starting from here, negative Vs plus 3Is, come here, minus Vx. And instead of Vx, you can also say 2Ix. That is also possible, 2Ix, because Vx is equal to 2Ix. But you come here, if this is Ix, so basically this would be 1 times Ix, the potential. So then when I'm come here, I hit a negative. So negative 1Ix. When you come back here, equal to 0. Okay, so this is important. Make sure you get this point. You could do that, or you could also name this another current I1, and then you write I1, and you can also go with that. And probably you need 1 more equations or so. But as you're getting more advanced, you can also skip extra equations. So what I did, for this one, I didn't have a current, so I just called, and this was plus and minus was given. Plus minus Vx was given. So therefore, I use the passive sign convention. I define Ix this way. And Ix is, if it's going that way, it's going to be also this Ix, which is good. But then when I'm writing the KVL here, as you see, we hit the minus here, negative, so negative Vx. And then you also because this is Ix going this way. So polarity would be here like this. So again, you hit the negative. So negative 1 Ix, okay? You can do this, or actually you could also say this way also. If Ix is this way, so negative Ix is this way. So R times negative Ix. So you had 1 times negative Ix. So as you see, there are different ways of looking at this one problem. So one can say, okay, you know what? If that's Ix, so negative Ix is coming here, and this is 1. So the voltage here would be 1 times negative Ix. Okay, you end up with this. As long as you end up with negative Ix, this should be correct. Okay, very good. So that is one equation. It has VSIS. It also has IX. Okay. So now let's look at the also KCL. So here, because we have a current source, we could also do a KCL here. So KCL. It's in the green point. Okay, it was on the yellow. Okay, KCL. So the summation of the current going out equal to 0. So negative IS. And then this one, negative Vx over 2. And then this one, which is negative Ix equal to 0. And remember, Vx was also, if you look at here, Vx was 2Ix. So let's also put it here. Vx is 2Ix. Okay. So now you have to put all these equations, you know, together. So first, let's get rid of the Vfx. So here on this equation, I replace Vx by 2Ix, so you get negative Is from that, negative Is. Minus Vx over 2, which would be 2Ix over 2, just Ix. Negative Ix equal to 0. So in other words, you get Is equal to, or you get Ix. 2Ix is negative Is. So Ix is minus half of Is. Remember, everything at the end should be Vs and Is, okay? So now I go back to equation number 1 and just replace Ix and Vx. So Vx was also 2Ix, so Vx was from here, 2Ix, 2I stat. Good, negative Is, okay? Okay, going back to equation 1. Negative Vs plus 3Is minus V of x, which is negative Is, minus Ix, which is minus half Is, equals 0. Okay, cool. So 3Is, 1Is, 4Is, 4.5 Is. 4.5 Is here, and then take Vs the other side. So Vs over Is equal to 4.50. Okay, and this is the R equivalent. Okay, so wrap up. We definitely put a Vs and Is here, and then you're looking for the ratio of Vs over Is. And then to solve this, I saw a loop here. I wrote a KVL on this. And then there was a current source here, and I wrote a KCL. So 1 KVL, 1 KCL. But when I was writing the KVL, okay, so let's review it again. negative IS plus 3 IS. I come here. Vx was given like this, so negative Vx. And then I came here, and there was also, I called here Ix. So if this is Ix, the other side is negative Ix. So 1 times negative Ix equal to 0. Okay. And what is V of x? V of x is 2ix. That's good, my another equation. V of x is 2ix. And then the KCL. Negative is, negative Vx over 2, negative Ix equal to 0. Okay. So V of x is 2ix. I replace in this equation. So therefore, I find a relation between Is and Ix, like this. Based on that, also Vs is twice Ix. That's twice Ix, and Ix was negative half Is. So we get negative Is. Okay, cool. So as you see, everything is become in terms of Is and Vs. And then I replace in equation 1. Negative Vs, Is, these are in terms of Is equal to 0. Eventually, Vs over Is is 4.50. Okay, very good. Now, if somebody says, what is the, for example, if you have this circuit, so from terminal A and B, if you can connect it to a source, you could also do that, right? There might be another part to this question. Okay, connect this whole circuit from terminal A and B. Terminal A and B, you had these circuits. How did it look like? You had this, for example, resistor, you had this current source, you had this, and you had that. Okay, now let's say somebody says for part B. I'm just creating part B right now. So part B, somebody says, okay, you know what? We connect these, let's say, even to another source. It might be even a current source or voltage source. Let's say, for example, 3 amp. Okay. Now, what is the, for example, the power of 3 amp? What's the power of this? Okay. Now, because you already have find the R equivalent here for this circuit, and it was 4.5. So you can replace this 3 amp and then 4.50. Okay. So now it's gonna be easy, right? So this 3 goes to this. Let's make it better number. So 2 amp. Let's say it was 2 amp. And so 4.5. So 2 amp is going there. So this voltage would be R times I, 9 volts. 9 volts. So the power for the current source 2 amp would be the current 2 times, as you can see, it's not a passive sign conversion, because if this is plus and minus 9 volt, the current should go there. So either you can say, okay, therefore negative 2 amp is going there, so negative 2 times voltage 9. Or you could say, you know what, it's a not passive sign conversion, so 9, you have a start with negative, then current times voltage. So anyway, it becomes negative 18 watt. So this is the power that the 2A generates. But interestingly also, so 18 watt generates 18 watts. But also we can say the circuit also somehow absorbs 18 watts. As you know, because the the power, we have a total power equal to 0. So if we consider also negative here, so we have a negative 18, which generates 18. The whole thing, you don't have to do all the, what's the power on this, what's the power on this. The whole thing, you can say the whole circuit definitely has to absorb 18 watts. So without further calculation, we will know how much this circuit absorbs power under this condition. Okay.